What's up YouTube, Jay here. In this video, I'm going to show you how to set up a reverse proxy with NGINX so that you can serve multiple web apps from a single server with a single IP address and not require the user to include the port when they're going to your site. So we'll talk a little bit about what that means exactly in the architecture and concept section of this video. As you can tell from the timeline down below, this is a bit of a long video. I debated whether to split this up into 3 shorter videos or go with 1 long video. And obviously I went with 1 long video. So if you have a preference, leave a comment down in the comment section below and I'll take a look and see what people like. The reason this is such a long video is because it is kind of all encompassing. I walk step by step through each setup thing and I explain what we're doing and I've explained how to validate that what we've set up is set up correctly. And the reason for that is because I think you'll retain the information much better if you actually understand what we're doing and why we're doing it and how to validate what we're doing. And it'll also give you a little bit more understanding. So in case you run into any issues during the tutorial, hopefully you can start to debug it yourself. If you can't, leave a comment down in the comment section below and I'll do my best to respond and get you pointed in the right direction. But hopefully this video will give you a deep enough understanding to be able to debug most things by yourself. All right, so what all are we going to go over in this video? We're going to start by talking about the architecture and the concepts of a reverse proxy. We'll talk about what it is, how it's set up, and why you might need a reverse proxy. If you're already pretty familiar with reverse proxies, feel free to skip this section. Then we'll go ahead and set up a server with some example apps on it so that we can point the reverse proxy at different apps to actually demonstrate what all we're doing. We're going to use a Linode Nanode. It's $5 a month. If you have the money to spare and you're interested in getting your hands on, I feel like you'll learn a lot by actually doing all this for yourself. And you can also shut down the Linode Nanode immediately after you finish the tutorial. So it'll cost you, say you leave it up for a day, it'll cost you like 30 cents, less than $1. Not too bad for a lot of learning. So we'll be using Linode, but if you already have a server with some apps running on it, you're absolutely welcome to use that. I'll show you how to connect via SSH and install Docker so we can run some example apps. But again, if you already have your server and you already have some example apps, feel free to skip this section. After that, we'll go ahead and set up DNS. So I have some domains. We're going to configure A records to point at the public IP address of our server. And I'll show you how to use a command line tool called dig to validate our DNS setup. Again, if you already have a domain name and you're familiar with DNS, feel free to skip this section. Then we'll hop into NGINX. So I'll show you how to install NGINX. I will show you the default NGINX configuration and how to remove that so we can replace it with our reverse proxy configuration. If you're already familiar with NGINX and you've used it before, you can probably skip this step. So after we've installed NGINX, we will hop into the meat of the video, which is configuring NGINX as a reverse proxy. So as I mentioned, we'll replace the default configuration with our own configuration, and we'll set NGINX up as a reverse proxy so that NGINX will receive all the requests coming into the server. NGINX will look at the host header, and then based on that host header, NGINX will route the request to a specific application. So rather than using the port to specify which application a request goes to, we'll look at the host header. So if you're already familiar with all of these things, go ahead and skip into the meat of the video, which is the NGINX configuration. Once we have all that set up, we will talk about HTTPS and why you should use it. We will install Certbot, which is a free tool to get free Let's Encrypt certificates onto your server. It handles all the domain validation. It also handles HTTPS certificate renewal, which is very convenient. So like I said, we'll install Certbot, and then we'll use Certbot to get those certificates. And then we'll update the NGINX configuration to use HTTPS using the certificates that we got from Certbot. So with all that said, I will get out of the way so we can go ahead and hop into the video. So first off, let's talk about what a reverse proxy is and why you might want to use it. I've also got a companion article up here on my website, on the blog, but let's talk about what a reverse proxy is and why you might want to use one. All right, so here's a little architecture diagram. On the right side, we have the server. On the left side, we have the clients that are making requests to the server. Any port number for an IP address can only go to one process. That's the actual purpose of a port, is to specify which process is receiving a request. So if we want to run multiple applications or multiple websites on a single server with a single IP address, they all have to use different ports. And that's fine, that can totally work, but it means that when a user goes to your site, they have to include the port in the address, which is not something that users are used to doing. But what we can do is we can put a reverse proxy in front of the applications. So all the requests from the users go on port 80, which is the default, which means they don't have to include a port. All the requests go to the reverse proxy, and then the reverse proxy filters based on the host header, which we'll talk about later in the video. So here you can see on the bottom right side, I've got 4 applications running on this server. So clients can make requests to the IP address of the server, and as long as they specify the port will determine which which process the request goes to. So port 5000 goes to red instance, port 5001 goes to green instance, etc. But with the reverse proxy, which we can see up here in the blue, instead of determining which application receives a request based on port, we look at the host header. So the host header is something that is attached to HTTP requests, or it's a header that goes with an HTTP request. So whenever a client makes a request, let's say to http red.jmartmedia.com, first DNS kicks in, the client asks DNS, the DNS system, which we're not really going to get into, what the IP address of this domain name is, and it will return the IP address that is assigned. So we come back, we have the IP address now, and then the client makes the request to the server with the IP address. And if you don't include any port, it uses port 80, which is the default HTTP port. If you want HTTPS for security, then you make the request on port 443. So if you're using HTTP or HTTPS and you don't provide a port, those are the ports that are used. So the client makes the request to the reverse proxy, and it has that host header, which in this case, since we're making the request to red.jmartmedia.com, the host header is going to be red.jmartmedia.com. The reverse proxy is going to accept that request, and then based on that host header, the reverse proxy will forward that request on to the actual application itself. The application will respond back to the reverse proxy, and the reverse proxy will send the request back to the client. So this is pretty common pattern for web servers. NGINX can do a lot of other stuff too. In this video, we're just going to be talking about the reverse proxy. So hopefully that makes sense as to why you can't have multiple apps running on a single port, because that's the purpose of port, to specify a process, but we can put a reverse proxy in place to route requests based on the host header. So now let's hop into a demo. So first off, we're going to create a Linode instance. I'm happening to use Linode just because it's pretty cheap to spin up, and then I'll shut it down whenever I'm done with this tutorial. We're going to use shared CPU. This thing's $5 a month, but since we're only going to use it for a few hours, it'll be less than $1. My Linode just refreshed. We're going to use Debian 12, which is, I think that's the latest. 13 may be out, I'm not sure. Go ahead and go with Georgia, shared CPU. We're using Linode, but you could absolutely use any other cloud provider, or if you have a physical machine, you could absolutely go with that as well. We're also going to go ahead and add an SSH key just so you can see how to do this. So on my website, I have lots of random helpful commands that I don't use very often, but when I do, it's kind of a hassle to find out what exactly I need. This will generate an RSA public key and an RSA private key. We'll put the public key on the server, and then the private key will just be on our machine. That way, when we SSH in, we don't have to enter a password. We can just directly connect. So I'm going to go ahead and run that here. And I'm going to put this, we're just going to call it desktop for now. Add a comment. I'm not going to set a password because this is just a temporary thing. And then now if I cd into the SSH, and we can see we have this desktop.pub. This is the public key, and then we have the private key. This thing you can share with people. They'll put it on the server, and it'll allow you to connect to that server with your private key. This private key you should not share. So I'm actually going to go ahead and pop out our public key, copy that, and we're going to add an SSH key here. Add that key. I already have a key set up, but this might be nice for anybody who hasn't used Linode before. Looks like we're good to go. So this is going to go ahead and start spinning up, and it'll take like 2 or 3 minutes to start spinning up. Once we have Linode set up, we're going to install Docker, and we're going to get some example apps running on Docker so that we can show how this reverse proxy works. Docker is not strictly necessary. If you have your own server with apps already running on it, you can go ahead and use those just fine, but Docker is kind of helpful for me to demo. Once we have this booted up, we'll go ahead and connect. Oh, actually, I can just boom. And we'll use our key that we just created, and it's called desktop. So once it started, okay, now our Linode instance is running. We can go ahead and connect. here we are. So this terminal instance on the left is always going to be the server. This one on the right is always going to be the client, which doesn't really matter now, but once we start making requests, it'll be helpful to keep in mind where we're making these requests from. So we're going to pop back into the article, and you can read through it yourself if you're interested. I also included the architecture diagram in here. We've installed Linode. Now let's install Docker. So these commands are coming from the Docker documentation for Debian. I'm going to go ahead and copy this and run it on the server to go ahead and install Docker. If we go back to the command, it's basically updating package registries, installing Docker, and then it's running just a quick Docker container to ensure that everything's set up and running, which test Docker actually didn't seem to run correctly, so maybe I didn't copy that. All right, anyway, I ran into some issues with Windows Subsystem for Linux pasting in multi-line commands to install Docker. So I'm going to go ahead and hop over into Git Bash and try it using Git Bash. So anyway, hopping back over to the article, I'm going to copy this. I'm going to have to highlight it, but I did anyway. There's our multi-line command. Again, doing some package manager things, installing Docker, and then running a quick test container. Yes, you can use some file system space. And if you want to find the actual source for this, you can go on the Docker site. All right, so now Docker is installed. Our Hello World image worked correctly, all good. Now let's go ahead and start up some Docker containers that we can use for debugging. So each of these is just a tiny little Node web API using Express, and just has a few endpoints that we can use for testing that our requests are going to a specific instance. So we have 4 instances, one running on port 5000, one running on port 5001, port 5002, 5003. And then they each return a slightly different message: red, green, blue, and root. Kind of similar to the architecture diagram here: 5000, 5001, red, green, etc. So if we run these real quick, we'll get these to start up. And there we go. We can see we have all 4 running. And if we curl localhost 5000, you can see we're connecting to instance red. 5001 is green, 5002 is blue, and you get the picture. And we can also make requests from our client if we use the IP address of the server. So in our architecture diagram, we've made requests from inside the server directly to the containers. Now we can make requests directly to the container from our client. You can see here HTTP the port the IP address, and then port 5000. So let's hop over to Linode. Here's our IP address. And then again, this right side is just going to be from the clients. So if I say port 5000, you can see we got red, 5001, green, all good. If we make a request to port 80, which we can explicitly say port 80, or if we don't include it, this is going to default to an HTTP request, and it will use port 80. We get a timeout because there's nothing there. All right, back to the article. So now we need to set up DNS. And what DNS does, in this case, we're just using DNS to map a human-readable domain name to an IP address. So we're going to be mapping red.jmartmedia.com to the IP address of our server. And we're also going to be mapping blue.crewviewer.com, which is another domain that I have and I'm not currently using, green.crewviewer.com to the same server. And we'll start seeing why we need this reverse proxy. So I'm going to go ahead and again grab that IP address, and I'm going to go ahead and show you how to set these DNS records. And these are all going to be A records, which is the type of record that maps a domain name to a IPv4 IP address. So here, this is in cPanel, which is a pretty common web hosting management tool. You can see we have rev.jmartmedia.com. Currently, it's pointing to this IP address, which is an old IP address for a different Linode instance I had. And we can actually get this A record if we use a tool called dig. And if we pass it, this makes a request to DNS, the domain name system, and it says, hey, I want any A records for this domain. So we come back and this is the IP address that we get. So now I'm going to go ahead and change this to our new IP address. This TTL is time to live. This is specified in seconds. So this IP address lives or is cached for 300 seconds, or I think that's 5 minutes. Yeah. So even though we've updated it, if I run this dig command again, you'll notice that I get that same IP address from before because that's cached by DNS. After 5 minutes, it'll be updated. You can also use the DNS checker tool to see what's propagated. So it looks like this is actually propagated out a lot, but it's still cached somewhere between me and the server, even though this random DNS checker website, the servers it's not cached in there, probably because the servers that this DNS checker website are using hadn't made requests to red.jmartmedia.com because it's a domain that isn't actually used for anything. So there would be no reason for it to be cached until I make a request. So we'll check back here a little bit later. But for now, I can go ahead and update the records in Namecheap. So this is using cPanel, this is using Namecheap. They're both doing the same thing for different domains, just I happen to buy the domains from different providers. So in here, go into Advanced DNS, you can see these are also A records. This @ symbol means it's the kind of root domain. This is the actual crewviewer.com. Blue is blue.crewviewer.com. So you can see it's a little bit different than what cPanel has, but at the end of the day, it's the same thing. And TTL is specified in minutes here for whatever reason, even though behind the scenes, it's still recorded in seconds. Let's go ahead and update these to our new IP address. There we go. So those will be updated in the next 5 minutes. Let's check back on our red.jmartmedia. Nope, still has got the old IP address. So once this DNS is set up, we'll be able to directly call the app using the domain name instead of the IP address, because all the domain name is doing is mapping to an IP address. If you don't have a domain name, there's actually a workaround you can do. You can edit your host's file, and here's the location of that host file if you're running Windows. Here it is if you're running Linux. And basically what the host file does is intercepts DNS requests and checks if the domain name is already found in the host file, and then it will return a IP address that way. So if I come into my host file here, I can add a new record, and we'll call it airplane. We'll call it .org because I don't even own jmartmedia.org. But if I save this, when you open the host file, I'll show you the location. You know, it's specified in the blog article too. You'll have to change text documents to all files, and here it is. You'll have to open it in admin mode, otherwise you can't save it because it's a pretty important file for your system. They don't want just anybody to be able to change it. Once I've set this, if I were to go to my client and say, dig it's now pointing at that IP address that I set. And if I curl that, then we'll get our app because this domain name is just pointing at our IP address. And there you can see we get instance red. Let's check. Oops. Check back on red.jmartmedia. Okay, and now the A record has propagated through DNS and we get our updated IP address. I'm guessing that the crew viewer ones are not updated yet. Actually, it is. Cool. So now we can curl. But the weird thing is, the host name isn't actually being used to determine which application the request is going to. The only thing that's specifying that is the port. So with any of these domain names, they're all pointing at the same server, the same IP address. It doesn't matter what I put in here. I mean, it does matter what I put in here as long as the domain name is pointing at the IP address of the server. But any of these can reach any of the apps, and you have to include the port, which is basically a deal breaker for any non-technical user. I mean, have you ever gone to a website and put in the port number other than something that you're working on? Probably not. So how do we fix this? And we're going to fix that by using the host header. And here's an example I can show you actually. If we look in the network tab, we can see here's the host header. And right now this host header isn't being used at all, but basically the host header is just the domain that the request is being made to. We're going to add an NGINX reverse proxy that checks this host header and forwards the request to the appropriate website based on the header, as opposed to the port. In fact, all the domains will all use port 80, which is the default. All right, so let's close these out. Done with this as well. So let's go ahead and install NGINX, which you can do by running these commands on the server. And this will install NGINX, and then it will start NGINX, which may or may not be required depending on how NGINX is configured. And now NGINX is actually running, and it's serving a web page on port 80. So if I curl localhost, and I could specify port 80, or I could just leave that since that's the default. And here you can see we have a web page, which is being served by NGINX. So if I actually come in here, and this will use port 80, here we go. So now if I go to red.jmartmedia, you see we get this same page because it's on port 80. All these domains are pointing at the same server. If we don't specify the port, they're all using port 80. They're all loading up the NGINX site. So let's take a look at the default NGINX configuration. And actually this should be updated. So NGINX comes with a default configuration, and we can take a look at it by running this command here just to cat out the default configuration. And you can see there's a lot of comments in here, but all of these hash symbols are a comment. But here we have a server block. And inside that server block, we're listening on port 80, and we're also listening on port 80 for IPv6. And we're serving pages from this directory. If we find the page, we serve it. Otherwise, we return a 404. That's basically all this is doing. So if we go here, var www.html, we can find the file that we're serving. So I can say var... My W key is actually messed up on this keyboard. And then if we cat this file out, you can see it's the same as what NGINX was returning when we curled it. So this is the file. We're going to go ahead and delete this default configuration because we're going to replace it with our own configuration. So we can just remove this default config. It won't change anything until we restart NGINX. And now we're going to start configuring NGINX as a reverse proxy. So I'm going to drag this onto the other screen so I can write this as we're doing it, but let's go ahead and change directories into the NGINX directory, and we're going to change directory into the confd directory. This is where we're going to put our configuration file. It's currently empty. We're going to create a new file called default.conf. If you name it with the extension .conf, NGINX automatically knows the configuration file, and whenever you restart NGINX, it will be loaded automatically. So we're going to go ahead and create that. You could use any text editor you want to use. You could use Nano or some graphical text editor. I like to add a comment about which site it's for. So we're going to create one for red.jmartmedia.com first. And basically what it's going to do is it's going to listen on a certain port, listen for a certain server name, and then forward that request to a certain application when it receives that request. So we'll create a server block, and inside that server block, we'll listen on port 80, and the server name, which isn't actually going to be used yet since we only have one server block, which I'll explain that in a minute. And then the root location is going to be just the root of the site. And so this is saying we're listing on port 80. Match this host name. And when you get a request on port 80 that matches this host name that's anywhere on the site, pass that request on to HTTP localhost 5000, which is one of our apps. I think that's the red instance that we have running. And actually, there we go. So if I write and quit this, this will cause any requests that are coming in on port 80 to go to the red instance when I restart it. So sudo system control restart NGINX. That'll restart NGINX. So now if I curl localhost, we get red instance because, again, any requests in here get sent here. And if I make the request from the client, you see we also get instance red. The weird thing is green.crewviewer. Oh, it went to HTTPS, but if it's HTTP, green.crewviewer also goes to instance red. And the reason for that is since we don't have a default server block, any requests that don't match any server block get sent to the first server block. In this case, we only have one server block, so all requests to port 80 come here, regardless of the server name. But we can add a default server block to catch anything that doesn't match. So let's go ahead and just default, and it'll be a new server block. List in on port 80, and then we have to give it the default server, which is a custom keyword in NGINX that says if you don't match any other request, use this server. And then we're just going to return a 502, which is a gateway error to indicate that, hey, something's up, your request is bad. And then if we restart NGINX, so now green.crewviewer will get rejected with that 502, but red.jmartmedia will return as expected. And we can add more server blocks for each of the other domains. So let's say blue.crewviewer, and then all we need to do is match the server name. And then we'll pass it, instead of passing to the red instance, we're going to pass it to the blue instance, which is going to be port 5002. So now save that file, restart NGINX. So now green still gets a 502 because we haven't specified anything for that, but blue should go to the blue instance and red goes to the red instance. So now you see we don't have to include the port anymore because NGINX is looking at the host header, which again, we can look at it here. If I remake these requests for red.jmartmedia.com, we have this host header as a request header, red.jmartmedia.com. For blue, we have this request header, blue.crewviewer.com. And again, that's what NGINX is looking at when it's determining where to route it. So I'll let the viewer determine how to get green.crewviewer up and running. But I think at this point, you should have enough information that you know you'll need to add a new server block, change the server name, and change the application that the request gets passed to. All right, so we're all good there, but we're only set up for HTTP. Stands for Hypertext Transfer Protocol, which it's insecure by default. So if anyone's sniffing your network, they can actually see all the content of your request that you're making. Fine for some cases, but not for anything that's remotely security sensitive. If you're sending a password over HTTP, anybody can just look at that request and read your password. So we can use HTTPS, which encrypts your traffic with a TLS certificate, transport layer security certificate, and we can do that using a tool called Certbot. If you did the hostname hack or hostname workaround, you won't be able to get a valid certificate for your domain because your host file change is only applicable to your client. It's not applicable to any servers in the domain name system, which it has to be available in the domain name system in order to validate your domain. So you won't be able to use this if you did the host file workaround. But if you didn't, we'll grab this command to install Certbot. And it also, we'll go ahead and yes, we want to do all that. So it's going to install a package manager called snapd, which is commonly used for Ubuntu. I think it's included with Ubuntu. Remove old versions of Certbot, and then we'll install new version of Certbot and link it up so everything is set up good to go. All right, so now Certbot's installed, and we can run Certbot in two different ways. One way, Certbot just gets the certificate. It validates that we own the domain, everything's good, gives us some free Let's Encrypt certificates. But then we have to make the change in the NGINX configuration file in order to enable them. The other way we can do it is let Certbot handle getting the certificates for us automatically. So we're going to do both here. First, we're going to get the one where we have to manually make the change, because I think it's helpful to understand what we have to change in order to set this up. So we'll go ahead and run that. So you have to provide an email that will be emailed if a certificate's about to expire. Pretty nice to have. I'm just going to toss this into a junk email because I'm going to get rid of this server anyway. Agree to the terms of service, and then marketing emails, no. And then here we can select the domain that we would like to get our certificate for. I'm going to start off with just getting it for red using this manual way, and then we'll do blue for the automatic way. So I'm going to put 2 and enter for red. Certbot will request a Let's Encrypt certificate, and it'll pop it on the server. You can see here's where the certificate is. Etsy, Let's Encrypt, live, name of the domain, and then the file name. So if we hop back into our default configuration file, we'll have to make a few changes here in order to add the certificate. We have this existing server block for listening on port 80. Now what we want to do is we want to create a new server block for HTTPS, which, if you remember from earlier, HTTPS is going to listen on port 443 by default. So we'll listen on port 443, and it's listening for an SSL connection. And then we're going to update our port 80, our HTTP block, to just redirect to the HTTPS version of the site. And we can do that by returning a 301, which is a permanent redirect. So this will redirect us to the same host, the same request path, but it'll redirect us to HTTPS instead of HTTP. So we're listening on port 443. Server name is going to be the same. And then we have to specify the location of our certificates. And we have the certificate up at the top, and then we have the key down here. My Vimming is not going very well. So we have our private key at the bottom, and then we have our certificate up at the top. And here in the HTTPS version of the site, we will actually forward the request onto the red instance. So go ahead and, oops, my W key is broken and it's really bothering me. So now we have the site up on HTTP, which just forwards you to the HTTPS site. It's not proxying you, it's actually forwarding the client to it. So now if we load up red.jmartmedia, right now you can see it's not secure, it's just using HTTP. But if we make this request again, would help if we restart NGINX. Now that NGINX is restarted, you see we initially load up the HTTP version of the site, and then we get immediately forwarded to the HTTPS version of the site, which is secure. And you can see we have our certificate, which is for red.jmartmedia.com from Let's Encrypt. If I, again, try and go to HTTP, you can see it automatically redirects me over to HTTPS. Now our blue is still just on HTTP. So let's change that. So we can use a certbot command, but now instead of doing cert only, we're just gonna run it automatic. If this is the first time you're running Certbot, it'll ask you for the email, the marketing emails, the terms of service, everything. Since I've already done that, don't have to worry about it. We've already set it up for red. Let's set it up for blue. So I'm gonna enter 1 there for that domain name. Hit enter. It'll request the certificate, and it'll automatically go ahead and do the update. And now if we look at our default.conf, you can see here's the block we edited recently. Here's our default server block. We had this blue crew viewer block down here that was only port 80, but now Certbot went ahead and created one for port 443 that's SSL. So it did all that for us, so we don't have to do it. Pretty nice. Let's restart NGINX, and so now blue, we're on non-secure. Now we're HTTPS. And we can look at that certificate, blue.crew.com, let's encrypt, and we're good to go. All right, so that's all I had for this video. I hope that's helpful for you. I hope it makes sense what you would use a reverse proxy for and how to set it up. If you want to read some more specifics, you can hop into this article. I'll include it down in the description below. As a quick recap, in this video, we learned what a reverse proxy is, created a virtual machine, installed Docker and some example apps. We learned a little bit about DNS, set up DNS to use an A record to point at the public IP address of a virtual machine. We installed NGINX and took a look at the default configuration. And then we started setting NGINX up as a reverse proxy to forward requests based on the host header as opposed to the port. And then we used Certbot to set up some HTTPS certificates to encrypt the traffic to the site. If you found the video helpful, give it a like so others will see it. If you have any questions or concerns, leave them down in the comment section below. And if you'd like to see more videos like this in the future, don't forget to subscribe. Have a great day.